Hello, Professor. My name is Joshua Rodriguez. My lab partner is Carlos Rodolska, and today I'll be presenting CECS346, Lab 6. So, the point of this lab is to create an IR sensor circuit that is functional. For the voltage source that I'll be using is a 9-volt battery. So, one thing to keep in mind is that the IR sensor is going to be connected to PF4, which is port F, pin 4. As you can see here, I also have all these defined statements in order to properly create the initialization for port F. So one thing to keep in mind is that we're going to have an unsigned long in, which is going to represent the input from PF4, or in other words, the input from the IR sensor. I also have two functions, port F init, which is going to initialize everything for port F, and enable interrupts, which is obviously going to enable the interrupts. So as you can see here, for my port F init, I make sure to set the system clock to activate for port F, and also have PF4 and to PF0 to be available for this lab. However, for this lab, we will most likely only be able to use PF4 as well as PF3 for this specific lab. However, we can also use the other ones in order to get the different results. So as you can see here, here's my main function. The first thing that's going on is port F init, which is obviously going to initialize the port F, which is what you're going to use for the lab. Then you have enable interrupts, which are going to enable the interrupts for the lab. And then during our while loop, we have in equals GPIO port F data R ANDed with 0x10, which is PF4. So what we're doing right now is we're reading PF4 into in. So in other words, we're reading the input, or we're reading PF4 into the input of the IR sensor. So basically, if in is equal to 0x00, which when it's 0, or when in is equal to 00, that means the IR sensor is detecting an object. That means it'll set GPIO port F data R to 0x08, which is going to turn the green LED on. However, if it's any other case, in other words, when this IR sensor does not detect an object, that means that it'll set everything to 0x00, or the GPIO port F data R set to 00, which is essentially when the LED is off. And we can confirm with this data table right here. As you can see here, when it's 0, it'll be dark, which means there's no color. And when it's 0x08, it'll be set to green. So let's turn on our circuit. Then we're gonna click save, build, and then load. And then we're gonna try and load it here. So as you can see, I'm loading right here. And then we have this right here. As you can see here, I have my 9-volt battery here. I have the two capacitors right here, and right here, and right here, as well as my LM7805 regulator, because right now we're taking in 9 volts, but then the regulator is going to output the 5 volts that we need. And then we obviously have V-bus. If you can see here, we have V-bus attached to all the circuits as well as ground. And we have this one right here, which is PF4 being connected to the IR sensor. So in order to make sure that this works, as you can see here, whenever the IR sensor detects something, as you can see here, it's showing that the LED is turning on, as you can clearly see. You see whenever you get close, but when I do it, that means it detects something. The LED on the right represents that the LED is functioning, or that the IR sensor is functioning. And then if we go over here, we can see that the IR sensor detects something. You can also tell right here by if you take a closer look right here, we can see that the green LED also lights, signifying that the IR sensor is indeed working as it's supposed to. So it could detect something. So that is it. Thank you for my lab, or thank you for allowing me to present this lab, and I hope you enjoy it. Thank you.